Hello everyone. Today I will show the solutions for the Prairie Math League High School Round 143 Problems 5 and 6. So for problem number 5, we have 2 points on the circumference of a circle with radius r that are selected independently and at random. And from each point we draw a chord of length r in a clockwise direction, and we wish to find the probability that the two chords intersect. Well, okay, so let's fix one of these points to be, Let's fix one of these points to be here, at the top, just for simplicity. So, this is R, and this is R. So in this case, here we have this blue region. So, we define this to be here, where this chord with length R hits here, and it extends all the way until the second intersection point of this chord. So basically what happens is that we'll show that any point in this blue region will have the two chords intersecting. So for this region, if the point is here, the chord will go somewhere here, the same distance here and here. And here we see that in this case, it will always intersect, no matter where we choose. So, yeah, for this other part, well, one point is inside this region and the other point is outside this region. So, of course, they have to intersect as well. Therefore, and we see that anything here or here, they just don't intersect. So this shows that this blue region is the region that we're looking for. Now, let's draw a point lines here. Notice that this is R, this is R, this is R, and we see that these are basically equilateral triangles. Hence, we have this is 60 degrees and this is 60 degrees, and we can choose this the second point anywhere on the circle. So, out of 360 degrees possibility, we find 120 degrees, which is the probability of 1 over 3. So the answer is D. Now for the second question, we consider the system of equations as listed here. Given that xyz is equal to 2 to the power of k for some k, we need to find k. Now, we first, for simplicity, let a equals log base 2 of x. Now, why log base of 2? Well, we see a log base 4 and we see a log base 8. And you typically, when you see powers of 2 like this, you want to use a log base of 2. Now, we do the same thing for b and c. And notice that since xyz is equal to 2 to the power of k, we have that k is equal to log base 2 of xyz, which is the sum of these since this just becomes a sum of logarithms, and we just apply the substitutions that we just defined. Now, notice that log base 4 of x is equal to log base 2 of x divided by log base 2 of 4 by the base change rule. Now, this is 2, so this becomes a over 2 here. And we can do a similar thing here, only that now we have to take the log base 2 of 8 in the denominator, which is 3. So, we apply this in a similar way, just changing things where things need to be changed. So here, this would correspond to this term, and the other two terms will correspond to this term, and a similar thing here. And now here's the thing, we need to find a plus b plus c. But this is kind of like symmetric, so we just take their sum, and we get this, or 7 over 6a plus b plus c, which is basically what we want. And now we just need to do a bit of basic algebra, and we get 66 over 7, which is a. And we're done. Thank you for watching.